The time to complete an exam is approximately normal with a mean of 60 minutes and the standard deviation of 10 minutes. Using the 68, 95, 99.7% rule, which is the standard deviation rule, what percentage of students will complete the exam in under 50 minutes? Every time we do this type of problems with a normal distribution, it is best to draw a normal curve. A normal curve is a bell-shaped one-peak curve. Label the mean in the middle, in this case 60, and we start going to the right 1, 2, 3 standard deviations away. Each of the standard deviation is 10, so we would label the right 70, 80, 90. Keep in mind that this is 1 standard deviation, 2 standard deviation, 3 standard deviation to the right of the mean. To the left, minus 10, 50, minus another 10, 40, minus another 10, 30, and these are minus 1 standard deviation, minus 2 standard deviation, minus 3 standard deviation to indicate that it is on the left hand side of the mean. Minus 2 standard deviation, the negative sign, indicate that this is on the left hand side of the mean. The question asks what percentage of students will complete the exam in under 50 minutes. Under 50 minutes, 50, is the same as saying below 50 minutes. So we locate number 50 on the horizontal line. These numbers on the horizontal line indicate the minutes. This is the number lines. They always go from the smaller number to the larger number. The number should be increasing. Any number on the left hand side is less than the number on the right hand side. We locate number 50 in the problem, 50 minutes, and we draw the vertical line connecting the graph to the horizontal axis. Under 50 minutes means everything that is less than 50 minutes. We are looking for the percentage that is covered the region on the left hand side of 50. This is the area of the shaded region, and we broke down the percentage of each region earlier. We saw that there are 3 separate regions in this shaded region. The first one on the left hand side of negative 3 standard deviation is 0.15%. Between negative 3 and negative 2, it was 2.35%. Between minus 1 and minus 2, it was 13.5%. We add these all up to get 16%. So to answer the question, what percentage of students will complete the exam in under 50 minutes? The answer is 16%. The 16% of the students will complete the exam in under 50 minutes. Notice that alternatively, we know that the mean separates the region on the left and on the right hand side to 2 equal halves. The entire area under the curve is 100%, all of the observations. Thus, there are 50% on the left hand side of the mean and there are 50% on the right hand side of the mean. We see that the percentage between the mean to the left 1 standard deviations away is half of 68 or 34. If we took 50 minus 34, we will get 16%. Another example, the height of American woman 18 to 24 years old fit the normal distribution with the mean of 64.5 inches and the standard deviation of 2.5 inches. This notation is read mu. It is the Greek letter mu. It is the mean that describes the population. This notation for the standard deviation is read sigma. The Greek letter sigma represent the population standard deviation. Since this is a normal distribution, we should draw a normal curve and label the mean in the middle. From the mean, we go to the right 3 standard deviations, and we go to the left 3 standard deviations. Keep in mind that one standard deviation is 2.5. Taking 64.5 and add 2.5, going one standard deviation to the right, we will get 67. Add another 2.5, we will get 69.5, and add another 2.5 to get 72. Going to the left one standard deviation, we will take 64.5 minus 2.5, which will give us 62, minus another 2.5, we get 59.5, minus another 2.5 to get 57. Keep in mind that we start with the mean mu in the middle. We add one standard deviation, add 2 standard deviation, add 3 standard deviation to the right, subtract 1 standard deviation on the left, subtract 2 standard deviation, subtract 3 standard deviations. Now, what range of height do the middle 68% of American women heights fall? Keep in mind that we broke down the pieces for the 1, 2, 3 standard deviations away from the mean, and we have the percentages of these pieces. 34% in the middle, 13.5%, 13.5%, 2.35%, 2.35%, 0.15%, another 0.15%. The percentage should add up equal to 100%. By looking at this detailed graph now, we see that 68% of American women heights would fall between 62 to 67. The answer for part A is 62 to 67 inches. B. In what range do the middle 95% fall? 95% of the observations are within 2 standard deviations from the mean, to the left and to the right, minus 2 standard deviation to 2 standard deviation. The corresponding height is therefore 59.5 inches to 69.5 inches. Answer to part B, 59.5 inches to 69.5. The unit is inches. C. What percentage of American women are taller than 69.5%? We're looking for the percentages now. More than 69.5% is on the right hand side of 69.5%, and it's not just 2.35%, but also 0.15%. To obtain all of the percentages on the right hand side of 69.5%, which is more than 2 standard deviations away, we would take 2.35% plus 0.15%, which will give us 2.5%. It is not enough to include 2.35%. We have to include both because both of these regions are on the right hand side of 69.5. C. The answer is 2.5%. D. What percent of American women are shorter than 62 inches? Shorter than 62 inches or less than 62 inches. So we would want the percentage on the left hand side of 62. There are 3 percentages, 3 pieces. We can add them all up. We will get 16% if we add them all up. Or alternatively, we know that on the left hand side of the mean is 50%. And we want all of these shaded area on the left hand side of 62. Knowing that half of this graph is 50% and this area or percentage from the mean to one standard deviation is 34%. We don't want this part, so we take 50% minus 34%. We will get 16%.